YouTube channel, Gaikwad Academy, Shirwar. Students, we are going to study the subject geometry, and first chapter of geometry is that similarity. The syllabus or contents of this chapter is definition of similarity, properties of areas of triangles, theorem of BPT, that is basic proportionality theorem, converse of basic proportionality theorem, application of basic proportionality theorem. There are two applications. One is the intercepts made by three parallel lines on their transversals, and second one is that angle bisector in a triangle. And now the second part of this chapter is similarity of triangles, definition of similar triangles, test for similar triangles, properties of similar triangles, comparison between similarity and congruency of triangles, and last one is that the theorem of areas of similar triangles. What is meant by similarity? The study of similar figures means similarity. Similar figure means the figures having same shapes and different dimensions are called similar figures. Examples are all maps in geography subject and all models of things are the examples of similar figures. Now, first topic of this chapter is that the properties of areas of triangles, which are depends on the heights and base of triangles. There are four properties. One is when the two triangles of same heights, then the ratio of their areas is equal to the ratio of corresponding bases. Second one is that when the two triangles of same bases, then the area of their triangles is equal to the ratio of corresponding heights. When the two triangles of different bases and heights, then the ratio of their areas is equal to the product of the corresponding bases and heights. And fourth one is that when the two triangles are of same base or equal base and heights, then the ratio of their area is equal to 1:1. That is, by cross multiplication, we get areas are equal. The first property is that when two triangles are of same heights, then the ratio of their areas is equal to the ratio of the corresponding bases. We can prove this property with the help of the formula area of triangle equal to 1/2 base into height. So when is the given and then is the true proof. With the help of the statement in the when, we can draw the figures. There are two triangles of same heights. So triangle ABC and triangle PQR, we can write given as in triangle ABC and triangle PQR, heights are same, AM equal to PM. After the then is the to prove area of triangle ABC upon area of triangle PQR equal to corresponding bases ratio BC upon. Proof says area of triangle ABC equal to 1/2 base of this triangle is BC and height AM Reason is that similarly, area of triangle PQR equal to 1 half into QR into PM. Here into prove the ratio of the area of this triangle. So give here statement number 1 and statement number 2 by 1 divided by statement number 2, we get area of triangle ABC upon area of triangle PQR. The value of area of triangle ABC is that 1 half BC into AM, and the value of area of triangle PQR is equal to 1 half into QR into PM. Here 1 half cancel, the division is 1 upon 1. Also heights are equal in the given AM equal to PM. Here AM 1 the PM. The reason is that AM equal to PM. So therefore area of triangle ABC upon area of triangle PQR equal to BC upon QR. Thus we can prove the first property of areas of triangles.